Good evening, students. So now we will discuss topics from Calorimetry chapter, part B. So in this chapter, we have to discuss with change of state of matter. So change of state of matter, first state of matter, change of state of matter, that is from liquid state to gaseous state, that is boiling. Now this boiling is a process in which a substance changes from its liquid state to gaseous state at a constant temperature and pressure. So in the definition we mentioned that it is done at constant temperature and pressure because if we change the pressure, then boiling point will be changed. So effect of pressure on boiling point, effect of pressure on boiling point, increasing pressure, number 1. So first point is increasing the pressure. So what will happen, like in pressure cooker, where we don't allow the steam to escape out, so this vapor pressure on water inside the pressure cooker increases the atmospheric pressure inside the pressure cooker. When the vapor is tightly closed and the vapor cannot come out, that vapor pressure basically increases the atmospheric pressure. Okay, so due to this increased atmospheric pressure, boiling point of water rises from 100 degrees Celsius to 120 or 125 degrees Celsius. So here we will write that boiling point increases from boiling point increases with increase in pressure. Example, pressure cooker. In pressure cooker, number 2, decrease in pressure. So decrease in pressure in high altitude, we can observe that water boils at a temperature lesser than 100 degrees centigrade. Why does this happen? This happens because atmospheric pressure is low over there. Okay, so atmospheric pressure decreases with altitude. We know that, we have read this thing in class 9. Therefore at these places water boils at a temperature lower than 100 degrees Celsius, which is quite problematic because this is not helpful for cooking. When water boils at a temperature below 100 degrees centigrade, so the vegetables, the materials, they don't get proper heat energy, so they can't be cooked properly. Okay, so it becomes very difficult and it takes a much longer time. Okay, so we can write here boiling point decreases with decrease in pressure. Example, in high altitude. Next, it depends upon impurities also. So boiling point depends upon impurities. So here I will add another bullet, addition of impurities. If I add impurity, then boiling point will increase. Like if I add salt to water while cooking, then we can see that it increases the boiling point of water. So here we will write boiling point increases with mixing impurities. For example, addition of salt in water. Next, melting. Melting is a process in which a substance changes from its solid state to liquid state. A substance changes from its solid state to liquid state. Okay, at a constant temperature and pressure. You have to mention that. Now, melting also depends upon few factors. First, pressure. Now, there are two types that if a substance contracts on melting, if a substance contracts on melting, for example, water. When water becomes ice, it expands. That's why ice is less denser than water. So when ice becomes water, it basically contracts on melting. So there are 2 points. First point, the substances which contracts on melting. This is a point. And another point is the substances which expand on melting. So the substances which contracts on melting, so their melting point decreases by increasing the pressure. So they contracts on melting, their volume decreases, so their melting point also decreases. So here I will write with increase in pressure, melting point decreases. Okay, so example is ice, anomalous expansion. So from class 7 only we are reading this anomalous expansion. Next point is the substances which expand on melting, example wax, butter. So in these cases, if I increase pressure, melting point will increase. Okay, so the substances which expand on melting, there with increase in pressure. So in both the cases, we increase the pressure to check the change in melting point. So we have observed that in this case, melting point increases with increase in pressure. Melting point also increases. Okay, understood? So here I have to highlight something which contracts on melting, there with increase in pressure, melting point decreases, and substance which expand on melting, with increase in pressure, melting point also increases. Then next, it also depends on impurities. Melting point also depends on impurities, like here I can write presence of impurities. For example, freezing mixture. Freezing mixture. What is that freezing mixture? Example, freezing mixture. So here what happens? The melting point of a substance decreases. Melting point of a substance decreases. So freezing mixture is a mixture of ice in salt in ice. Okay, we mixture in a proportion, we mix salt to ice. Okay, we add salt to ice, and this mixture is called freezing mixture. Okay, adding salt to ice. Next, so melting, boiling done, and during boiling the temperature remains constant at boiling point. So here I will write one thing: during boiling temperature does not change, remains constant at the boiling point. Okay, so here I will write the amount of, so here I will write specific latent heat of vaporization. What is that? The amount of heat energy that will be supplied, the amount of heat energy that will be supplied to change the state from its liquid state to gaseous state. That is called specific latent heat of vaporization. Specific latent heat of vaporization is defined as the amount of heat absorbed the amount of heat absorbed during boiling during boiling, amount of heat absorbed during boiling per unit mass without any rise in temperature. Without any rise in temperature. Okay, okay. So specific this is called specific latent heat of vaporization. Specific latent heat of vaporization. Next, come melting. Here we have to write during melting temperature remains constant. Temperature remains constant at melting point. Temperature remains constant at melting point. The amount of heat energy, it's a general definition, the amount of heat energy absorbed during melting without any rise in temperature is called as amount of heat energy absorbed per unit mass amount of heat absorbed per unit mass during melting by the solid. Who will absorb? For example, ice is melting, so ice will absorb energy. Okay, so amount of heat energy required to melt ice, so ice requires the heat energy. Okay, so absorbed per unit during melting without any rise in temperature is called specific. Ice requires that heat energy. Without that heat energy ice will not melt. Like if I say specific latent heat of fusion of ice is 80 calorie per gram, what do you mean by this statement? So you have to write कि 1 gram ice at 0 degree centigrade requires 80 calorie heat energy to convert into 1 gram water at 0 degree centigrade. Okay, specific latent heat of fusion. Now the next type of question, what do you mean? So if I write, the next type is what do you mean? It's a very common question. What do you mean by the statement that specific latent heat of fusion is 336 joule per gram. What is that? 336 joule per gram. What do you mean by this? The answer will be, see, it is given specific latent heat of fusion. That means ice will be changed into water. Solid state will be changing into its liquid state. So I have to write, and here it's specific latent heat of fusion of ice. Sorry, fusion of ice. So I have mentioned the particular solid also. So here I will write, I know the melting point of this solid. So here I will write 1 gram, its unit mass. Specific latent heat of fusion should be started with the unit mass, per unit mass. So 1 gram ice at 0 degree Celsius, 1 gram ice at 0 degree Celsius requires 336 joule heat energy to get converted into, mass will remain constant definitely, 1 gram water at 0 degree Celsius, because temperature will remain constant at its melting point. So 1 gram ice at 0 degree centigrade requires this amount of heat energy to get converted into 1 gram water at 0 degree centigrade. That means temperature remains constant and there is change in the state of solid to liquid without any change in temperature. Okay, without any change in temperature. Okay, without any change in temperature. This is called specific latent heat of fusion. Understood? Of ice. Similarly, if I ask you specific latent heat of vaporization of water, then you have to say 1 gram water at 100 degrees Celsius. You have to mention unit mass. You have to, so the three things that you have to remember here. The first point is the three things that you have to remember. The first point is the melting point or boiling point here. Melting point or boiling point. Melting point or boiling point. Then you have to mention the change of state. The change of state. Then you have to mention the unit mass. The unit mass of the substance. The unit mass of the substance. Okay. So these three things you have to mention in this question.